Welcome back. Today we are going to discuss a very important topic. It's Cisco administrative distances. How does a Cisco router select the routes if multiple routing protocols are on the devices? Well, let's take a peek at some information here. This website, Route Selection in Cisco Routers, explains it very well. And it's interesting to note that the last time this was updated was back in January 2nd, 2008. Now there are newer documents, but I just wanted to find one that was quite old to demonstrate that this has been around for a long time, even longer than this. This is probably quite old, but it's nothing new. But in your studies, I wanted to demonstrate that you have to memorize this table right here, default administrative distances, because this is what decides what gets placed in the routing table. So if you have multiple protocols on your devices, they will all learn the routes, but what gets installed in the routing table is based on these administrative distances. So if we eliminate eBGP, which is 20, which is the lowest out of the routing protocols, then we see that eIGRP always wins over. Now connected routes have a 0, which can't beat that. 0 is the most important route there is. Anything that's connected will always win over static, will always win over eBGP, eIGRP, and so forth. So you need to memorize this table. eIGRP has an administrative distance of 90. IGRP, which no one uses, is 100. OSPF 110. ISIS 115. RIP 120. And then eIGRP also has these external routes. And IBGP is 200. eIGRP summary route has a 5. Wow, that's very impressive. So when we take a look at this on the command line, we'll see how this plays out. So let's take a look. Here we have just basic 4 routers, and I'll just start configuring these. These have no configuration on them. So let's go as fast as possible so we don't waste your time. So I'm going to rename this host R1, and let's just use interface G00 goes to R2. So I'll configure this IP address 10.10, and we'll use the 12 network for this. Last octet will always be the router number, which is 1. And we'll no shut it. Interface G01 goes to R3, so we'll use 10.10.13.1, 255.255.255.0, no shut it. We'll create a loopback interface that will represent the router number. So all octets will be 1.1.1, 255.255.255.255, 32-bit mask, and that is it. So right off the bat, we'll start configuring router RIP. We'll do version 2. It's the latest version. We don't want to use old stuff. And let's just put in here our network. And regardless of what we put here, it will translate to a 10 dot completely. Network 10 thing. We'll put our loopback interface here as well. Let's configure router eIGRP 1 router. Let me spell things right. eIGRP 1 network 0.0.0 255.255.255.255, and this just means every single interface. We're just trying to get there as fast as possible. Router OSPF 1. We're going to up arrow since it's the same command and just add area 0. Control Z to get out of configuration mode. Show run section, and then we'll do router. So there we have it. Router eIGRP, all interfaces. Router OSPF, all interfaces. Router RIP, we'll do the 1 network and the 10 network. This is done. Let's go to router 2. Same deal here. We'll configure this. Host name will be R2, interface G00, IP address 10.10.12.2 because it's the router 2. No shut it. Interface G01, IP address. Now this is going to router 4. So router 4 will have a 24 because it's between 2 and 4. .2, 255.255.0, no shut it. Interface loopback 0, IP address. Remember, this will be all the exits of the router name, 255.255.255. Okay, router RIP version 2, network 2.2.2.2, network 10.10.12.0, network 10.10.24.0, router EIGRP 1, network 0.0.0.0.0. And just remember, when we do this, is a wildcard mask here. So if you haven't seen any other of my videos, let me just mention that real quick. So if it was a 24-bit mask, I would do this, okay? Because the last octet would be the one that represents what we want. But we want to match on everything. So that's why we put that, meaning every single interface will be part of EIGRP. Okay. Same thing holds true with router OSPF, up arrow, and then just add area 0. And we should be done. Show run and section router, and that's it. We have it there. Let's go to router 3 now, and the same thing. Host name R3, interface G00 points back to R1 IP, so that'll be in the 10.10.13 subnet. 255.255.255.0. One extra tab there. No shut. Interface G01. IP address 10.10. And this is a new subnet. 34 because it's going between router 3 and router 4. No shut that. And no shut. Interface loopback 0. They don't want that. No, interface loopback 09, interface loopback 0, IP address 3.3.3, 255.255.255, and that's a 32-bit mask. Router RIP, net version 2, network 3.3.3, network 10. And we can just put 10.0.0. That's what it's going to translate to anyway. Router EIGRP 1, network 0.0.0.0, 255.255.255.255, router OSPF 1, and you can see the adjacencies popping up. We are done with this one. Show run, section router. And if you just want to show, for example, RIP, you could do show run section RIP and so forth. Okay, so we are done with router 3. Okay, how's it looking? And if you're enjoying this far, well, please subscribe. Please join this channel. I will keep updating this, creating new videos. So now let's go to router 4. Move it over so you can see the drawing. Okay, same thing. Host name R4. And I'm doing this as fast as possible. You could slow it down or speed it up or move a little bit forward if you don't want to see these parts. 10.10.24.4, 255.255.255.0. No shut. Interface G01. IP address 10.10. This is between router 3 and 4. 255.255.255.0. No shut this as well. And then interface loopback 0, IP address 4.4.4, 255.255.255.255. We do a router RIP version 2, network 4.4.4.4, network 10. Router EIGRP 1, network 0.0.0.0, 255.255.255.255. Router OSPF 1, up arrow this a couple times, area 0. We're done with our configuration. Okay, so what's the idea here? Well, let's take a look at all our protocols. We can do that here. Show IP RIP database, which tells us all the networks it has directly connected, any of them that it's learned. So router 4 has already learned of the 2 network, the 1 network, which represents the loopback interface. And we have all that there. Very nice, right? If we look at show IP EIGRP, what are our options here? It's the topology. We see 10.10.12, 34, 24. We see the loopbacks. If you look at it, has 2 routes for that. So we're doing pretty good here, I would say. Okay. Show IP OSPF. What are our options here? Do neighbor. Show IP OSPF topology. Show IP OSPF database. So we're learning, each protocol is learning what it needs to learn. But if we do a show IP route, what do we get? Here's the interesting thing. Who is the preferred router or the preferred routing protocol? So we see RD, 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 C, D, D, D. If we look at what these mean, D is EIGRP, R is RIP, O is for OSPF, and OSPF has 3 entries. OIA, which is OSPF inter area, and then it has this one and this one and this one, more than 3. Should have been more specific about that, but we're looking just for O since we're not doing any of the other fancier stuff. We're just doing basic area 0, but that doesn't even show up. What is the reason behind this? Do you know? Well, remember, if we go to our documentation, it says these are the ways the routes get preferred, and it will always prefer EIGRP. Always. Now, why does it show RIP routes? Well, it shows RIP routes because it's showing the class full network 1.0.0.0/8 network. So what happens there is this route will never get used. It's just not necessary because there's the other rule of routing, the longest match. EIGRP is matching on the full 32-bit subnet for 1, and it has the 2 routes for it, as you could see. Once again, for the 2 network from router 4 to router 2, yes, it has this route in there. It's a 120, which is the administrative distance, but the longest match rule is this one, and it's a 90. EIGRP is 90, RIP is 120. The thing here with this basic network, and it really doesn't matter how big it goes, the routes EIGRP will always be preferred. It's just the one with the lowest administrative distance. And here we're just talking about IGPs. We have to make that distinction. If you look at eBGP, which is an exterior gateway protocol, and it's more like an application than a routing protocol, this is a 20. So of course, if we were ever in an environment where we have an eBGP route, then that would be preferred. But we're not talking about that. We're only talking about IGP routes, and that's why this one is preferred. So if you memorize this table here, that'll help you with your studies. It'll help you with your troubleshooting. It'll help you with a lot. And I know sometimes it can get hard. But the other day I was trying to remember one of these, and I say, well, wait a minute, how can I not remember this when this is, I talk about this all the time. Sometimes it just leaves you, especially with routing protocols that you never use. So actually I was thinking about what was the RIP administrative distance, because I haven't used this pretty much ever, and not in a production environment. So RIP, to me, it's not even worth it to study it, but you need to know it for exams and so forth. But for production networks, I don't think you will ever need to use RIP. I don't think. It could be out there, but I've never experienced it, because there's just such better protocols like EIGRP, OSPF, ISIS has made a strong comeback. So it's one that I need to spend some time on as well. But there we go. There we have it. All these routes there. And as you could see, it's preferred to use EIGRP because of the administrative distance of 90. So this is just a great way for you to practice your administrative distance studies, the Cisco route selection process. It makes things very, very interesting, because you can start troubleshooting, you can start learning how things work together. A lot of times it's not just about knowing one thing, it's really about learning how to interact with different protocols, different devices, different hardwares, different vendors. And right here, it's just a simple, how do multiple routing protocols interact together? Well, I hope you've enjoyed this video. Give me a like, please subscribe, please hit that notification bell. We'll be back.